Right, so we're talking about the manufacturing industry. How do we increase profits? By increasing the number of products that our factories can produce out in a day. How do we do that? What factors influence that? The speed of our machines and the amount of errors and the amount of failed products that fail to make it through. Our tennis ball packaging machine aims to solve both those problems. Here, let's go over how it works.
Before we made the real machine, we need to design 3D model. And this is our 3D model. You can see we have used many materials such as acrylic or aluminum, and there are some special parts that we need to use a 3D printer to make a workpiece. We have divided into two main parts. There is a upper part, this, and lower part here. In the upper part, it have two solenoid. The two solenoid have a role like a barrier that can block the ball and transfer the ball into the canister. And we made a program that it can work together. In the lower part, we have a load cell to measure the weight of the canister with the ball. And the method that we use is at least we must have at least 3 balls. After that, the solenoid will transfer the ball to the canister one by one. And if the load cell measure that there are 3 balls in the canister, this rotator plate, it will rotate and send a new canister without the ball. But the rotate plate cannot know that the new canister is in the correct position or not. So we need to use a limit switch. If the limit switch trick, it means that the new canister is in the correct position. And this will go in loop.
Next, we'll go over the monitoring dashboard. Our machine can be controlled and monitored both locally and remotely. The remote dashboard here, this white one, is hosted by NetPi, and this is the local dashboard hosted by Node-RED. On this dashboard, we are both able to control the machine by turning it on and off, see the status of the machine, and see how the performance of the machine is working. For example, we can see how many packages is shipped, how many errors has occurred, and the average time it takes for each package to go through. Now, while this machine works as is, it's a massively inefficient design. For example, if we rotated this tube up here to be fully vertical, we could save space in the factory, which in turn would make us place more machines. Or we could move the valve, the gates here, to deposit 3 balls at a time to increase the speed of depositing, which would also increase the number of products we can ship out in a day. Or we could change out on the materials that we use to construct the machine to save up on manufacturing costs. Now, this machine is automatically able to package the tennis balls and use the weight sensor to check for any errors. This will reduce all the human errors that occur usually in the packaging process. While this is almost perfect, I think that we should all aim to reach 100% automation in every single factory. Now, while we're all working towards that, I understand that it's very hard, but I think that automation engineering is the perfect faculty to solve this problem. And I think that we should all continue to support this industry. So thank you very much.